Okay, so we've spoken a bit about some of the challenges, but what are the scientific principles at work here? What do we demonstrate?
We're demonstrating the relationship between pressure and volume. So what that means is here is that as the pressure decreases, the volume will increase. So it means our balloon will get bigger as it rises through the atmosphere, and it'll reach a point where it'll burst. It just cannot stretch any further. And this comes from Robert Boyle. In the 17th century, discovered the relationship between pressure and volume. And he said really that for a closed system, for a fixed volume of gas, the pressure is inversely related.
Yeah.
Related.
Okay, so we're going to ask again, and Irish.
Yes, Irish.
Okay, so we've got a bit there. So the we'll go from Robert Boyle, I guess. We've got a bit. So that's the principle at work. Who discovered this principle?
In the 17th century, an Irish scientist called Robert Boyle discovered the relationship between pressure and volume, and he came up with an equation to describe this, which means that for a closed system, for a fixed volume of gas, pressure is inversely related to the volume. And if you actually multiply the two together, you would get a constant, a fixed quantity all the way through it.
Right, so he worked this out back in the 17th century?
Back in the mid-17th century.
And this has been at play ever since?
We use this every day in our normal lives. So a very simple example would be if you're going on a flight and you buy fizzy drink. What's the correct term?
A carbonated drink. Fizzy drink?
Carbonated. Nobody uses carbonated.
Fizzy drink.
Fizzy drink.
Absolutely. Fizzy drink.
That's correct.
Yeah. So this is a principle that's at work every day, is it?
That's right. One example would be if you're going on a flight and you buy a fizzy drink at the airport. When you go up in the plane and open it, you'll find something splurge. Expand. Let's take a bit easier example.
Well, you don't have to have an example. Well, your ears pop, but that's another thing. Planes are pressurized. It's the reason planes are pressurized because of the decrease in volume, in pressure outside. But that has an effect, obviously. Fizzy drinks, if you open a fizzy drink on the flight, it'll explode out.
Correct term for
ejaculate.
It's one way of putting it.
You just splurge out like an enthusiastic teenager on his first date. Jizz all over your face. No, you can't say that. In fact, this is all recording, isn't it?
Yes.
This is my usual film. I'll have to take care of the edit. Thank God it's not mine. So okay, so we've said about the principle at work. We've said a bit about Robert Boyle. We probably just need to go over Robert Boyle again because it's a choppy. Okay, so that's the principle at work is the fact that a gas will expand as the pressure decreases. So the volume of the gas will increase as the pressure outside decreases. That's going to make our balloon grow and eventually burst. Who discovered this principle?
In the 17th century, an Irish scientist called Robert Boyle discovered that relationship between pressure and volume. And he's known for coming up with Boyle's law, which means that for pressure P and volume V, if you multiply two together, you will get a fixed quantity. Now, this is for a closed system and for a fixed volume of gas. But we use this principle every day and we don't realize it.
Very good. Thank you. That's fine for that, I think.
We take it for granted.
Yeah.
We take it for granted, tends to be a better term.
Okay, I'll have a look at it again. Okay, so we're sending this balloon up from Valentia with the help of the Met Office. Do we have any idea then what's going to happen to it? How do we know where it comes down? And does that present any difficulties?
Just before that, do you want to mention the Met area in Valentia?
Yeah, I think it's worth mentioning.
Yeah.
Okay, so there are people who send balloons up every day. That's the Met Office. So we'll be sending a balloon up. Just going to ask them to show up slightly. Keith.
Hello, Martin.
How are you? So what are we talking about now? We're going to just talk a bit about the retrieval, because that's the bit we didn't go into a lot of detail, and it is a bit of a challenge. So I'm just going to ask you about the difficulties in finding the balloon, tracking it, and then finding it, and what could go wrong. We have a balloon that's going up into the atmosphere of 30 kilometres, whatever. It's going to go pop, thanks to Robert Boyle, and it's going to plummet down to Earth. So that sounds a bit risky. What are the challenges involved in tracking where that lands, and what could go wrong?
And there's quite a lot of interesting challenges. Let me start again. There are a lot of interesting challenges with launching a balloon, and one of those is how to track it, and then another one is how to retrieve it afterwards. So this balloon will travel unmanned. It's at the mercy of the winds and the atmospheric turbulence, and we don't know for certain where it's going to land, but we can track it and plan in advance for the retrieval. So we track that using a radio tracking device. We've also, with the help of Met-Éireann, we can work out in advance where we expect it to travel using a modelling system. And the retrieval then hopefully would land on ground, on dry ground. I'll do it again.
As opposed to...
most likely scenario, water.
Yeah, because we're surrounded by water and we're on it.
Everywhere.
Yeah. So, that being the case, so if it lands, if we're lucky and it lands on Earth and not water, it's somewhere in the country, how do we then retrieve it?
If we're lucky and the balloon lands on ground, we'll then have to drive to a location which we can find from our mapping system and hopefully retrieve this. The balloon, when it bursts, the payload will be guided to Earth with a parachute.
So it's not going to plummet through somebody's front porch and ruin their Sunday, kind of thing. Okay. Grant, so we've got, we've mentioned tracking, payload, weight, retrieval. We've talked a bit about the science element and Boyle. We've talked about, we haven't mentioned too much about Boyle himself, and we won't. We haven't spoken about permission to launch, so I might just ask you a question about that. Can anyone just launch a balloon? See if it's serious. So, can anybody just go out into their backyard and, if they've got a weather balloon, just send it up into the sky? Are they allowed to do that?
It's not possible in Ireland, because in Ireland we have a very busy airspace with a lot of aircraft overhead passing each direction every day. So the only group allowed to launch balloons in Ireland is Met-Éireann. So as part of the weather forecasting service, they launch balloons on a very, very regular basis to assess the state of the atmosphere, temperature, pressure, and winds. So with their help, we're carrying out this experiment.
And where do they launch those from?
Those balloons are launched from Valencia, in the south of Ireland.
So it's not the airspace isn't too busy there.
That's right. In that area of Ireland, the airspace is less busy than it would be over, say, the Midlands or Dublin region.
And I wonder, can they track the prevailing winds a bit better? Okay, so that's grand. So we've kind of covered everything really, I think. I've been filtering Boyle as well, Boyle, tracking, permission to launch. That's pretty good coverage. We can put something together on that. Cool. Really nice. The graphics. Sweet.
Graphics as well. Graphics as well.
Not a whole lot.
Hand drawn.
That's going to actually, that sounded okay.
1, 2, 3, 4, 5. Hello, Martin.
And is that was the volume you were speaking at, I think?
Yeah, 1, 2. We're going to launch a balloon from Valencia. It's going to fly to 30 kilometres. It's going to travel for 14,000 miles and land somewhere in Western Australia.